psig is normal as glycol flows through the elements. The pressure drop increases as the elements remove solid material and eventually become plugged. When the pressure differential becomes 15 to 20 psig, the elements should be replaced to prevent stoppage of the glycol flow and possible collapse of the elements. For removal of dissolved contaminants, activated carbon filters are used. When the glycol contains measurable quantities of light hydrocarbons, the carbon filter must be changed or reactivated frequently. Most glycol systems cannot be operated successfully without carbon absorption. Now, there are two types of activated carbon filters. Small systems like this one use a carbon canister with replaceable cartridges. Larger systems use a loose fill carbon vessel that use granular activated carbon. When the loose fill vessel is used, carbon particles, sometimes called fines, must be trapped to keep them from entering the glycol dehydration unit. This is especially important when a fresh carbon bed is put into service. Anytime the level of contaminants in the glycol increases, the carbon filter should be replaced. Monthly tests should be run to determine contamination level. The regenerator is a combination of the glycol reboiler and the still column. They work together to regenerate the rich glycol, making it lean again and ready to use in the contactor column. The reboiler supplies heat to separate glycol and water by simple distillation. Glycol is heated to a temperature between 380 degrees and 400 degrees Fahrenheit to remove enough water vapor to regenerate the glycol to 98.5 to 99%. The temperature of the triethylene glycol should not exceed 400 degrees Fahrenheit because TEG will begin to break down at higher temperatures. Reboilers can be direct fired or heated by steam or hot oil. The direct fired type, containing a removable firebox and fire tube, is normally used. An overflow weir maintains the glycol level in the reboiler. Excess glycol spills over the weir and flows downward into the surge tank by gravity. When the glycol level is low in the surge tank, fresh glycol is added to the reboiler, so it can be dried before going into the surge tank. This still column, or stripper, located just above the reboiler, is where the actual distillation of water from the glycol takes place. Still columns are normally packed columns and have fin condensers or reflux coils in the top. These condensers, or reflux coils, cool water vapor leaving the column and recover entrained glycol. The amount of glycol lost with the water vapor leaving the still column is controlled by the temperature of the water vapor. Now, this temperature, called the still overhead temperature, should be set at the boiling point of pure water. Normally, the pressure will be atmospheric, 14.7 psia at sea level, and the temperature will be 212 degrees Fahrenheit. Systems operating above sea level will require lower temperatures due to lower pressures. Systems with back pressure will require higher temperatures. If the still overhead temperature is above the boiling point of pure water, glycol carryover is the result, and losses will be higher than normal. If the still overhead temperature is below the boiling point of pure water, too much water will be condensed back into the glycol. This will cause both the reboiler heat requirements and fuel usage to increase. When the glycol flow rate exceeds maximum design limits, a condition known as column flooding occurs. Column flooding is when the still column fills with liquids. This occurs when the glycol being fed to the still column has a high concentration of light hydrocarbons. These hydrocarbons distill out of the glycol and condense in the upper portion of the column. Column flooding does not allow proper glycol and water separation. Rich glycol can be lost through the vent line when the column floods. Now, the surge tank stores regenerated glycol for pump suction, and it is commonly positioned under the reboiler. Vapors, which are trapped in the surge tank, could cause a circulation pump to vapor lock. Therefore, a vent line is provided to remove these vapors from the surge tank. Most small dehydration units use a fluid-driven pump, while larger units generally use electrical-driven reciprocating pumps. In either case, the pump is a critical part of the unit because it has the only moving parts in the system. Now, before the rich glycol enters the pump, it passes through a strainer to remove large particles. Leaks can be a problem around glycol circulation pumps. Proper packing land maintenance and the use of the manufacturer's recommended packing can minimize this problem. There are two types of heat exchangers used to cool the glycol in a glycol dehydration unit. Glycol to glycol heat exchangers, like these, and a glycol to gas heat exchanger. Now, lean glycol leaving the surge tank must be cooled prior to entering the contactor. The cooling allows the lean glycol to absorb the maximum quantity of water from the gas in the contactor. The heat exchangers are very important in the overall operating efficiency of the dehydration unit. They substantially reduce the amount of heat required by the reboiler and allow a maximum gas drying in the contactor. The first stage of glycol cooling occurs in the glycol to glycol heat exchangers. These two heat exchangers cool the lean glycol coming from the surge tank at 400 degrees Fahrenheit to a temperature of 212 degrees Fahrenheit. The final stage of lean glycol cooling occurs in the glycol to gas heat exchanger. Dry gas leaving the contactor passes through the glycol to gas heat exchanger, where it cools the incoming lean glycol to a temperature about 10 to 15 degrees Fahrenheit, above that of the natural gas entering the contactor. On small dehydration units, this exchanger is often a double pipe heat exchanger, which is literally a pipe within a pipe. Lean glycol in the outer pipe flows around outlet gas in the inner pipe. Larger units may utilize a shell and tube type of heat exchanger. Taking the temperatures of glycol before and after passage through the heat exchanger tells you what condition the exchanger surfaces are in. As the exchanger surfaces become more severely fouled, the temperature differential across the heat exchanger decreases, meaning that the exchanger isn't as efficient as before. When this occurs, you will need more gas to fire the reboiler. That wraps up the second section. In it, you saw the individual components that make up the glycol dehydration unit, how the components work together, and how the components work together to dehydrate natural gas and to regenerate rich glycol. All right, take some time now to read over this section in your student manual. Review this videotape if needed. Then when you're ready, answer the questions at the end of this section. Now in the next section, we'll see the importance of glycol conditioning and ways to reduce glycol losses. See you shortly.